Wilde is CEO of American Amplifier Technologies, Shively Labs, Catherine Broadcast USA, and SWE Services. He has more than 20 years of experience in the broadcast communications industry with electrical engineering, tower construction and maintenance, and manufacturing as his principal areas of focus. Steve holds a bachelor's degree in electrical engineering. Steve?
All right. Well, so I was going to show off our EmPower VNA and our EmPower control system. So I'll go through the slides, not too many slides. I'll probably we brought our scaled range, so we'll show that off, and then we'll come back to the our different control products that we're showing off. All right, so our EmPower product is all of our different control systems. We have power, voltage monitoring and control systems. We have standard remote controls. We have controls that are just bringing in SNMP data. So from all your different transmitters or your SNMP devices, you can bring in those different devices and then a unique platform that you can connect with your smartphone or your iPad and view those different devices and configure custom thresholds and alarm set points. So that's our EmPower system. And our latest addition to the EmPower system is our EmPower VNA. So our technology partner is Copper Mountain. So we've taken the VNA and we've let that be an option in our control system. And we've written some software that communicates with that VNA and displays it on the controller. Then allows you to have access to the VNA as well to do sweeps. So how we're configuring that VNA is through a directional coupler at the system, and you can take frequency domain and time domain sweeps of your transmission system with the transmission system operational. So we're going to go through that a little, but short PowerPoint, and then we'll dive in. So why transmission line monitoring matters? Downtime. It's the difference between being on the air or off the air. So downtime equals loss of revenue. Emergency repairs are expensive. Traditional inspections require time and a reactive component to it where you don't know where the problem's at. You have to go to the site, break the line, and troubleshoot. So the EmPower VNA solution, frequency domain and time domain, you get both. All those features that you usually get with a VNA, you get with this product. On-demand analysis integrated within the EmPower platform. So you'll get alerts on your smart device, push notifications, all cloud-based, easy access to the data and automatically alerts you. So this is a typical configuration. So you have your transmission system, you have the directional couplers, which we have up here. So we'll demonstrate that here in a sec. And then you have your antenna system and the VNA, it's injected through the directional couplers. So you can see that simple configuration. So as we've all done with VNAs, you can break the transmission line and connect the VNA directly to the transmission line via adapter, right? That's what we typically do. All we're doing is taking the VNA and injecting it through the directional couplers. So we can do automated sweeps. We can detect anomalies, the trace data reference, which we'll show, the app integration, automatic reporting, and giving you direct access to the VNA. So you can log in. It's price effective. It's an economical option within our control platform. You log in and have direct access to the VNA and do the sweeps whenever you'd like. You don't have to go to the site and put an adapter on. You can do those sweeps anytime. Prevent costly downtime, extend the equipment usage. You can know about a problem before it happens. save on expenses and inspections. If you're doing that annual sweep, you can now do that remotely. And peace of mind 24/7, knowing that your transmission system, you can log in, you can have access to it, you know what the impedance characteristics look like throughout the whole system, time domain, frequency domain, and all of our other control platforms that you can pair with your control unit. So we'll dive in. So this is our antenna under test. That's our receive antenna. So we'll go ahead and we'll do dual polarization, both vertical and horizontal. So this is a scaled 4.5:1 ratio. And we've written some software. It works with a network analyzer. So we're sharing the VNA today. And one of the cool things it's fun to play with is on our range here, it's normalizing the pattern as it's turning. So as it's turning, it's putting in the data. So it's a log periodic slant. So then it goes over to horizontal. We'll measure the horizontal component. All right. Yeah, so it normalizes automatically as we're turning. So we see the relative field azimuth pattern. And as we can see, we got too much horizontal. If we wanted to equal that out, we'll give it a try. So Mike's going to change the slant for us. So this room, we're getting some interference, but we moved around the transmit and receive a good bit yesterday to try to minimize the interference, but we are getting some scatter and reflections. All right. So definitely more vertical now. Cool. So we use a scaled range at our facility in Sacramento, California. And then we use HFSS as well. So we use both, and both are wonderful tools for us. But historically, Shively for a very long time has used the scaled range. We've continued that. But we do work heavily with HFSS for all of our patterns as well. Transmitter just came up. So if you want to show off the EmPower controller, and your screen's on the big screen right now, so everyone sees you. This is the EmPower controller, looking at all of our control devices that we have here today. And we're going to demonstrate a fault. So I'm going to pull out we have a dummy load here. I'm going to turn on the carrier. There we go. So we have our EC unit, which protects and monitors the incoming source voltage, electrical voltage for the equipment. We have our transmitter. We have a power meter that's monitoring the forward and reflected power. We have our directional couplers paired with our VNA. And we have our EmPower controller that's monitoring all of our devices and using a VNA as well. Okay, so transmitter's on. Let's just demonstrate first. So we have a low voltage scenario. You can see that. And then on our iPad, we get an alert right away that a fault condition has occurred. So a push notification. All right, so let's make sure our VNA is working, Andrew. All right, cool. Let's save our reference file. So we're actually seeing the trace data here. All right, so that's our reference file now. So as it brings in new sweep data, if anything changes, it'll alert. So what I've done is I have an 8th wave open stub here. So the transmitter will be able to operate into that, and it allows us to have a fault that'll occur in the system alert us, but it simulates a fault at the transmitter, or excuse me, at the antenna, near the antenna. So we'll go ahead and install that stub. we can right away, we got a fault detection. We know where the fault's at. And we got an alert on our iPad through our app that we have a fault condition, a TDR alert. All right. Well, any questions on that?
So my question was, if the VNA was still active, would continue to be active if the transmitter was off? That's what I was asking.
Yeah, we're not using the transmitter voltage for the VNA. So the VNA is injecting a narrowband signal into the directional coupler, and we're analyzing that with the second directional coupler. So first directional coupler is where we're injecting, just like what we would if we're direct connecting. We're just getting the signal on the line via the directional coupler. So a reflected port on the directional coupler, we're typically measuring with a spectrum analyzer. So from the antenna, the direction to our spectrum analyzer, right? But you can, in the opposite direction, if you were injecting, then that signal would go towards the antenna. So we're just using the reflected port and a directional coupler to inject the signal. And then we're calibrating with the second directional coupler to the forward port. And then we're measuring with the reflected port for a receive port for the VNA on the second directional coupler. Just like what you would with a network analyzer connected directly to the transmission line. We're just using it in a unique way of injecting the signal and allowing that VNA product to be available through the control system. So it's an economical way of having VNA data of your transmission system that is operational. So, yeah.
Questions?
What frequency band does that signal, which is inserted, operate?
You can adjust it, but so we're using you'd want to use a frequency band outside of your fundamentals. So we're sweeping outside of the fundamental, which is an FM.
Follow up, sorry.
And what assurance do we have that that signal is not being radiated by the antenna in a manner that exceeds FCC limits?
Yeah, we're staying well below the out of band emissions with the signal level. So we're using very, very little signal to analyze the circuit, similar to what you would be doing with a VNA directly connected. Thank you.
All right, thank you very much, Steve.
Yeah.